All right, there are two ways that I handle these kind of unit conversion questions or rate questions. The more traditional way is to just use ratios. This isn't a complicated situation, which is why that might be the best way to do it. What I usually do is I focus on the question itself. What's my X? How many minutes does it take the machine to pit 96 pounds of cherries? So I like to set up a set of fractions, and I really focus on the X because I love to have the X on the top. It really doesn't matter, but yeah, it's kind of just the way I like it. So I would say, okay, X minutes, how many minutes to do 96 pounds of cherries, okay? So basically what we're taking advantage of is if something is a constant rate, then the fraction can kind of grow and shrink, but the overall value of the fraction will be the same. So we're using just like the properties of reducing fractions here. So we want to create another fraction to set this equal to that continues the units. So notice I wrote my units down because if I flip it, then I'm going to be wrong. So how many minutes? Now that's got to go on top. 3 minutes for 12 pounds of cherries, right? So the units need to match up. Then the way that many of you learned this is just to cross multiply. You could do that here. You can do 12 times x and 3 times 96. That is okay. The reason I don't love cross multiplying though is it kind of confuses people who struggle with fractions as it is. When we do normal multiplication of fractions, right, we go across the tops, across the bottoms. And now you're being told to kind of go diagonally. And so this kind of just messes people up. So here's the better way, I think, to think about a situation like this. If our x is on the top, our first move in any equation is to simplify stuff that we have. So we could just take this 3 and 12 and simplify that. So grab your calculator. It's okay for us to have decimals. So that's 3 divided by 12, and that is 0.25. So let me rewrite this now. X over 96 is equal to 0.25. Now, our general rule in algebra, when we don't have any variables, is to get x alone, right? So x right now is being divided by 96. How do you get rid of division in math? Well, we use the opposite of division, which is multiplication. So if we multiply by 96 over 1 on both sides, and I'll just do it as times 96 here, that gets rid of this, and it leaves us with x equals 0.25 times 96 is 24, which is the answer. There we go. That is a nice way to do it. This is just simple ratios, but I do know that the SAT is going to, in some cases, add in more conversions for us to do. They sometimes just like maybe make us go from minutes to seconds or minutes to hours or something like that, where it's just a little bit extra. And if we have that extra step of another unit, it's harder to work it into our fractions, right? This ratio setup really works best when we just have 2 units, in this case, minutes and pounds. If we add in another unit, it's a little harder. So the other way to do it is to create a little bit of a chart. So let me show you the way I would do that. Basically, just take any rate that you see in the question. So we don't even need to start with the x here. We can just start with the beginning. We have 12 pounds and 3 minutes. So you're writing one number from the rate on the left side of our chart, the other number on the right side. And then our goal is to get rid of all the units. And in order to do that, we have to have a unit on the left side and on the right side. So now I see, okay, I also have 96 pounds. So I would write the 96 pounds here so that now I have the pounds on the left and the right, so pounds are gone. The number stays, but the unit is gone. And I need to get rid of all the units. So I need to get rid of minutes as well. So I need to have a minutes on the left. And in this case, since it's such a short problem with very few steps, it's just an X here. Okay, so we can have an X in this chart. It's fine. And that lets us get rid of minutes. And now we know we've incorporated all the information. So again, if there were more units in this question, if they wanted us to convert to hours, we would have another line to deal with that conversion. But here, once we're done, we just kind of multiply down. So 12 times x is 12x, 3 times 96, 3 times 96 is 288. And what we're doing is now we have created a equation, and we just solve that equation. So 12x equals 288, and we would solve that the same way we did before. We try to get x alone. In this case, though, 12 times x, we wanted to get rid of multiplication. We use division, so we're going to get x is equal to, let's just make sure I'm doing this right, divided by 12 is, sure enough, 24. So I know this is a long explanation for something that's generally an easy question, but I feel like if you're watching this, it's because maybe these kinds of questions bother you, and even if you got the answer, maybe you just need a little refresher on how to do it in a formulaic way. And I think the formula is very important here because of how the SAT twists things up by adding in extra units and extra conversions and just like wording it in weird ways. So if it's a very simple 2-unit question, probably stick to the left side and do ratios. But if it gets more complicated, this chart method allows us to include lots of conversions in one thing and then just deal with all the math that those conversions entail at the end. So if you kind of search my channel, you'll find some YouTube, some unit conversion questions, and then you'll see when it really gets complicated how this chart method works best. But hopefully this was a nice refresher to kind of get you going in both cases, no matter what type of question they give you.